Hello everyone. In this presentation we are going to see one of the important key exchange algorithms, which is Diffie Hellman key exchange algorithm in our subject cryptography and network security. This is the outline of this presentation. First of all, we need to know the importance of key distribution algorithm. Second, the ways to exchange the keys, and then one of the main application of Diffie Hellman key exchange algorithm and the algorithm of this key exchange algorithm with its example. The first thing, in our daily life we are using chat applications to send or receive messages with anyone. Have you considered these messages are really sent in a secured manner? How it is possible? Let's consider two persons, Henry and Stella. They want to exchange the messages in a secured way. For this operation, they need to encrypt the message with the help of any key. Then, so that we are going to formulate a key. Then the next step is, how does we exchange the keys between these two users? Let's see. So we are creating a key to encrypt the message, and our main task is to exchange the keys between these two users in a secured way, for which we are having an approach for Diffie Hellman key exchange algorithm. Before seeing that algorithm, let's see the key hierarchy. We are having two types of keys. One is session key and another one is master key. Session keys are temporary keys and it is valid only up to the logical connection is alive, and master keys are used to encrypt the session keys. Let's see it. The actual data is protected with the help of session keys and the session keys are protected with the help of master keys. Let's see the ways of key distribution. Normally we are having two types of, the major categories are symmetric key distribution as well as public key distribution. In symmetric key distribution there are two ways, symmetric encryption as well as asymmetric encryption. For exchanging the public keys we are having four ways. One is public announcement, second one is public available directory, third one is public key authority, and finally we are having public key certificates. Let's see one by one. The first thing is public announcement. In public key announcement, the users can broadcast their public keys to any of the recipients in public manner. But the weakness here is the keys are vulnerable to access by anyone and they can claim the identity of the actual person. The second type is publicly available directory. Here is the directory is there. The users can register their public key in the directory so that others can access the public key via electronically, and also it has the vulnerability as tampering or forgery effect. The next one is public key authority. Here there is one authority. That authority will create public keys and it will distribute the public key to the sender or receiver when the user approaches the authority. The next one is public key certificates. Here the certificate binds the identity of the user within the certificate and all the contents are signed by the public key authority, and these contents can be verified by any third party to check the identity of the user. Let's see how to exchange the secret keys. Till we are seeing how do we exchange the public keys, and hereafter we need to exchange the secret key, that is a single key used between the users, between the sender and receiver. How do we exchange the single secret key? For that we are having one algorithm, one popular algorithm which is known as Diffie Hellman key exchange algorithm. So it is an algorithm to securely exchange the secret keys, and it was proposed in 1976 by Diffie and Hellman. It can be possible to send the keys over the insecure channels. So let's explain with an analogy, that is we are having two users, that both users must have a private color set and they must decide on a common public color set to be used. That public color set is used for further communication between the user. So there are two persons, sender and receiver, they are having unique color set red and blue. With this color set, we are having one common colors yellow. These two colors are combined with the common color and it will create some different colors, orange and green. These two colors are exchanged between them, and also through the secure channel there is a possibility to get the colors by the hacker. After the exchanging, they are using their unique color set red and blue. They mix the color set, finally they are getting the same color set. So that is the working principle behind the Diffie Hellman key exchange algorithm. This is the algorithm. Before initiating the algorithm, we are having two key components. One is prime number P and Q is generator. After that, these two key components are publicly available to anyone, that is the sender and receiver also know the value, as well as the hacker can also know the value. First thing is, at the sender side they are having their private key XA, and at the receiver side they are also having their private key XB. So X indicates hidden, so XA and XB are the private keys of users A and B correspondingly. One of the constraints is these two values are less than the generator value Q. Then after that, in both users side they have to calculate their public key YA. YA is equal to Q power XA mod P and YB is equal to Q power XB mod P. Q is the generator value, XA and XB are the private keys of their one. After that, YA will be exchanged to user B side and YB will be exchanged to user A side. Then they will calculate the key value like the received public key from user B, YB power XA mod P, and then received public key value YA from user A power XB mod P. After that, these two values will be the same, AK and BK will be the same. Even though the hacker may get the values of P and Q and YA, YB, they cannot find out the value of AK or BK because of the properties of modular arithmetic. So let us see with an example. Initially they are having two numbers, one is prime number 13 and another number is 6. 6 is the generator of the prime number 13, and both the users have to choose their private key from at user A side the private key is 5 and user B side the private key is 4. So it can be represented as XA equal to 5 and YA is equal to XB is equal to 4. Then next thing is at both user side they have to calculate their public key, that is YA and YB. The formula is XA power, that is the formula is G power XA mod P and G power XB mod P. Let us see, the first thing is 6 power 5 mod 13. We need to calculate with the help of calculator, like first we need to calculate 6 to the power of 5, the answer is 7776. We need to calculate the modulus value. Modulus is the remainder when the number is divided by one divisor. So the answer is 0.153 into 13. So the answer is 1.989. We have to consider it as 2. And at the user B side, we need to calculate 6 to the power of 4 mod 13. Similarly, we can calculate as 6 to the power of 4 divided by 13, and we need to only focus on the decimal points, 0.692 into 13. The answer is 8.996. So we can consider it as 9. These two values are exchanged between themselves. So 2 comes here and 9 comes here. To calculate the shared secret value, the formula is the received value to the power of XA, unique value mod 13, and the received value 2 to the power of XB mod 13. So 9 to the power of 5 divided by 13, omit the whole numbers and take the decimal points 0.2307 into 13, the value is 2.99, can be considered it as 3, and in this side user B side 2 power 16, we know this value directly. So, 16 divided by 13, so 0.2307 into 13, the answer is 2.99, which is 3. So, we can share the secret key value without exchanging through the secured channel or insecure channel. We can calculate the key value at both of the user side, we are getting the same value. Let us see the applications of Diffie Hellman key exchange algorithm. It is mostly used in VPNs, virtual private network, for communicating with the remote servers and the client machines. We are using Diffie Hellman key exchange algorithm, and in online banking applications and to secure the email application, we are using Diffie Hellman key exchange algorithm itself. So, in this presentation we are seeing the need for key exchange and what are the types of key exchange algorithm, and the major type of key exchange algorithm is Diffie Hellman key exchange algorithm, how it was, and the applications of Diffie Hellman key exchange algorithm. Thank you.